This is a quick test of a project I've been working on lately, which is controlling a robotic arm using kRPC. So you can see this is our arm that we're going to use. We've got a servo and a hinge at each joint, including the top, and then we've got a small claw at the top. And we've got our robotic controller here, and you can see this is a track editor for the controller. So if we bring up our kRPC program, this is it here. And we will first connect to kRPC. So we're connected, and we can see that it's populated the vessel parts, and you can see that the base piece for the arm is this servo here, which is that one there. So we're going to set that as our base arm, and we'll load the arm, and you can see it automatically loads and names the axes. This one doesn't load properly because it doesn't update the last one, but if you open it again, it will be there. So then we are going to create a new robotics part here. You can see we've got a model of the arm here, and what we'll do is we'll set a line target, which is a path between 2 points. This, set the endpoints, and then you'll see that's our, actually we'll make that a little bit longer. Okay, so you can see that's our target. We've got a start and an end point, and we want the end of the target of the arm to follow that path there. We've got our segments that we're going to use, which is how many points along this path do we want to solve for. And then we are going to look at the locking the arm, which is locking not the arm, locking the manipulator. So what direction do we want to lock that in? And we're going to lock that in the Z direction, so coming this way. So it's going to stay flat through the whole path. So we'll lock that. Clamp just clamps the rotation angles so that the hinges don't go past 90, because they can't go past 90, so the values that we calculate won't go past that. And then we will do a path solve. So there we go. You can see it's snapped to the last position, and you can see it's in line with the direction that we want. So we can do a frame animate, which will let us see it go through all of the positions that we've given it. Pretty easy to see. And then what we're going to do is we are going to set the arm parts, which will map through all of those positions that we calculated to the proper component. So it's going to snap to position if I go like this, but that's okay. We've limited the traverse rate for all of them to 20, which makes it a little bit, a little bit easier to deal with. So now we'll run it through, and you'll see what happens. Okay. Yep. So you'll see it follows the same path as the one that we have here. You can see it stays flat all the way through. Just here, you can see what it looks like. And then we can reverse the path, play it back. You can see it runs through. You can see it does a little wobble there because it's switching from one end to the other with the servo at the end. So that's why we use a lot of segments on the calculation, so 100 in this case. is to avoid it snapping and flying around, trying to rotate all the way back around the other way to get to the target. And that's also why you drop the traverse rate right down low, so that even if it tries, it can't get there very quickly, so it's not going to snap around or anything. So the plan is to kind of add some more complicated pathing. Like this is just a simple line at the moment. Add more kind of shape stuff, add some more things into it, like grabbing objects with the claw at the end, or some other things. Obviously the stiffness of the arm is a bit of a problem, and it tends to droop a fair bit, but otherwise I think it's a pretty good start.